Everybody, we're in Unit 11, Solid 3D Figures. So today we're going to be looking at some basic ideas, area, perimeter, and what we call nets. And to make sure that you understand, as we move forward in 11.2 and 11.3, these basic ideas are going to be really important for you to understand those and make it easy. All right, let's go ahead and get started. Okay, we're going to start with some figures here and make sure that you would be able to identify them. If you need to copy them down or draw them on your own, you go right ahead. So the first one up to bat is called a rectangular prism. The reason it's a rectangular prism is that we have two sides that are rectangular. That's rectangular. And then the top here is rectangular. Okay? And so because those two are rectangular and parallel to each other, we're going to call it a rectangular prism. Notice that those two, the top and the bottom, are connected by other rectangles. Okay, but the fact that the sides are rectangles is why it's called a prism. The reason it's called a rectangular prism is because the top and the bottom are rectangles. Now, take a look at this next shape, and we have a triangular prism. Okay, so when you look at this, just like the rectangular prism, the main shape is a triangle, and that's why it's called a triangular prism. Okay, so in this case, the top and bottom are triangles. In the sides are once again rectangles, and that's why it's called a prism, is that the sides are rectangles. Okay, so that's a rectangular prism. The next one is a cylinder, and you're probably pretty used to that one, comfortable with that one. You've seen it a lot in your life. The next one, a cone. You've probably gotten an ice cream cone. This one's upside down, so it's no good to me. The next one is a pyramid, and what we find out is a pyramid, this particular pyramid has a rectangular base, or actually a square base, but the sides are made up of triangles, okay, and that's what's making it a pyramid, and they all meet at a top peak, and so this is called a pyramid. And then the last basic shape that we're going to be looking at is a sphere. Okay, so let's get started. Let's continue on. Okay, so by the end of this video today, you should be able to check off these I can statements. I can measure the perimeter of a two-dimensional figure, and I can measure the area of a two-dimensional figure. Okay, so looking at these basic shapes, we have the basic shape here is a rectangle. So area is length times width. So we would just simply, to find the area here, we could take 12, the length, and multiply it times the width. Okay, and that would give us 60. Now, this is in feet, so the unit of measurement for area is in squares, so we'll call it feet squared. Now, the perimeter is the distance all the way around it, so we're going to transfer that 5 to here and the 12 up here, and I get a total of 54. That measurement is a distance measurement. It's not an area measurement, it's a distance measurement, and so the units are going to be in feet. Okay, so here we are with a circle. So you need to know the area of a circle. In this case, it's pi r squared. Now remember, r is the radius. In this case, we're given the diameter 14. So the area is going to be pi 7 squared. I'm going to keep my answer in the terms of pi. So I'm not going to multiply it by pi. Since it's given as feet, the area is feet squared. Make sure you don't forget to put your units on these things. Perimeter. Now, the perimeter in a circle is really called the circumference, and we know circumference to be 2 pi r. Now these are all formulas that you should be writing down so that when you get to class and we're practicing, you have them to call back on. Okay? So the circumference of this figure is just basically 2 times pi times 7, which is let's see, 14 pi feet. Again, circumference is a distance, a measurement. And so that's going to be the same units as given. All right, this next one is finding the area and eventually the perimeter of this triangle. Okay, well, the perimeter is an easy one. Again, perimeter is all the sides added up. So this one's going to equal 20. Let's say that this is in inches. That'll make it easier for us. That's in inches. So the perimeter there is 20 inches. All right, so the next thing I want to do is find the area. So the area of any triangle is 1/2 base times height. So we need to understand what the b, the base, and the height mean. So in different triangles, depending on how it's set up, the height could be like here and here. And this triangle, the height is given on the inside, and the base is here. And then finally, in the one that we're working on here, we might have the height is on the outside, and the base is once again over here. Okay, so just so you can identify the height and the base, the height is always going to have the length, if you will, of the altitude, the thing that runs from a vertex down to another side and has a little right angle on it. Okay, so here's the height of this triangle, so you know that's the height by the way it's illustrated, and the height always touches the base. Okay. On this last drawing here, that's going to be a kind of a anomaly. If you can see, the base is way over here, the altitude is way over here, but we extended the base. It's still the side that we extended. The base is still the side that we extended for the height. So looking at the figure, you have to be able to identify what is the height and what is the base. Okay, so if you take a look at the triangle here, I've drawn in blue where the altitude, if you will, is of this shape, okay? So we had to extend the base out to get the altitude. So the base in this problem is 4, and the altitude is whatever this number is, okay? So we'd have to either use something to calculate that or whatever. All right. Okay, so now we're looking at this trapezoid. The area of the trapezoid formula is 1/2 height times base 1 plus base 2. Of course, these are the base 1 and the base 2. The height, though, is the number that's going to be on the inside here. That height right there, we'll just put it there. Now, I want you to know that sometimes the height is given by showing the height, like over here, or the, oops, or over here. I don't know why it's not doing that. Something like that, okay? So sometimes we go looking for the height or they give us the height. But in any case, those are the pieces that you're going to have to put in for the area of a trapezoid. All right, the last thing is something like this, okay? So this is what I'm going to call a regular figure. We know regular figures from back when we were dealing with polygons. Regular figures all have the same angle, and all the sides are the same. You need to bring that A to the outside there. Cool. So to find the area of this thing, the formula is 1/2 little a big P, okay? And sometimes the P is lowercase p. In any case, the P stands for perimeter. If you just add up the sides. And the A is what we call the apothem. And it's the distance from the center of this thing to one of the sides. And it's usually given to us in some more advanced classes. We might use right triangles to find it and stuff like that. Okay? So let's continue. Okay, so using that formula, I want you to go ahead and calculate the area of this shape. Go ahead and put me on pause and come back and check your work. All right, so I wrote the formula down without anything in it. I got 1/2 Apothem times the perimeter. I calculated the perimeter. There's 12. There's 8 of those 12 sides, 12 length sides, and so the perimeter is 96. And the apothem is given to me as 14.5. And there you have it. It's that easy. Let's move on. Okay, and this next kind of things that we're going to need to check off, you need to be able to look at a solid, identify a solid that would be formed by a given net. And these are called nets, where you have the shape basically cut open and it laid out flat. So we have to identify what kind of three-dimensional shape that would eventually look like. So take a second, just imagine taking those triangle pieces and folding them up and see if you could draw the figure that it's going to look like. See you later. All right, so that's what the figure should look like, okay? So we're going to do a couple of these. To be honest, I don't know how to teach this. This is one of those things where you have to just think it through and practice and put it together in your own way, okay? So watch me draw this one. I first of all identify how many sides there are. 1, 2, 3, 4, 5, 6. So I'm just going to 1, 2, 3, 4, 5, 6, okay? The more I do it, the better I get. Notice I didn't make it look like that shape. I kind of leaned it on its side, and you just get good at this, right? So I can tell this thing's going to come to a point because of the history of it, and all the sides are triangles. So I'm just going to connect the points, and that'll create triangles, and that's what that net's going to look like. That's the three-dimensional shape. All right, see if you can do this one. This time we're going to try to put the numbers into the shape after it's drawn, okay? So go ahead and put me on pause. See if you can draw this one. So there I am starting the base. And then I kind of sometimes draw in the back lines dotted so it kind of makes it look like that. So now let's draw those that length in. So it goes from the peak down to one of the sides. It's perpendicular, and it looks like it's 20.4. Okay, so that would be the height of that triangle. And then the apothem goes from the center of the pentagon to an edge. It's perpendicular, and it's 9.6. So I kind of drew this altitude over here. I shouldn't have done that. I'll draw it to the side over here. That way they can kind of coexist peacefully on the same one. So here we are, 24.4. Okay, so you should be able to draw something like that. If you're having trouble drawing these, you know, you can either come and see me and we work on it, go see an art teacher, or you can just say you don't know how to do this, and you know you're not going to be able to get credit for that in the class, okay? So this cone is made up of two shapes. We've got the bottom shape and then this side. And most people don't know this, but the side that's like a cone, or the side that's kind of comes to a point, is really a circle with a wedge cut out of it. And then the rest of it is a circle. Okay, so that's how it all ends up being a cone. So we'll take on the circle and put a radius of 9, and then the radius of the circle on top is given as 26.6 units long. All right, see if you can put together this shape. I'm going to refer to my professionally drawn one that looks like that. All right, let's move on. All right, so one of the I can statements is I can identify the base of a three-dimensional figure, and I can measure the perimeter of the base of the three-dimensional figure. So to find the base, all I'm going to do is I'm going to choose, you know, what is the major shape here? The major shape here looks to me to be this figure here, and there's two of these, and so I know there's one on the bottom. So to find the perimeter, so first of all, that's a pentagon, so we would identify it as a pentagon. We'd identify that the base as being a pentagon, and this is a pentagonal prism. Okay, but to find the perimeter, I just simply add up the sides of this thing that make up the perimeter of this. Okay, sometimes they put some of the information on the top one, sometimes they put it on the bottom one. All I'm care about is that 8, and it gets repeated all the way around, so perimeter is equal to 40 inches. All right, let's take a look at this one. So identify what the bases are, what kind of shape they are, and then find its perimeter. Put me on pause, come back and check your answer. So it's definitely a triangle. Okay, so to find the perimeter of that base is, well, I'm going to go ahead and draw it. It's a triangle, and I know it to be a right triangle because that one's the same. Around the right is a 3 and a 4. And I'm going to steal this 5, which is the same as that side right there, 5 feet. Okay? So now I've seen problems where that 5 feet is not in there, right? So you'd have to find this side on your own, right? Call it X. Use Pythagorean theorem, whatever. And there you have it. There's your homework, your try it problems. I'll scroll through it so that you can see it in a little bit bigger format. Have a fantastic day. Have a great day.